29.18 has two wires in it. You can see one of them is a cardboard tube. The lighter one is the one that seems to be underneath. Okay, there's winding over there. You can see it's winding so that it goes from left to right and down to up. So that's the direction that it's going. If you were looking at the tube from the left-hand side through the tube, the cardboard tube, to the right-hand side, it would seem to be winding in the counterclockwise direction. Okay, that's good. And then you have winding B, which is sitting on top of it. It's wound in the exact opposite direction. If you were looking through the tube from the left-hand side through to the right-hand side, it would seem to be winding in the clockwise direction. And at the end of that is a little resistor. So they're asking for a bunch of different situations what's going to happen to the what's happening to the current through the resistor. Okay. So first we're going to talk about each of these three situations, what's happening. So first, in the first one, the current is from A to B and is increasing. So what does that mean? Well, first let's talk about so it's from A to B. So if it's from A to B, then at this point on the wire, the current's going like that. That's the direction of the current. Okay. If the current's going like that, and you use your curly right-hand rule, you run your thumb along that, then the magnetic field going through the tube, this is through the center of the tube, not the outside. The magnetic field through the center of the tube is going like this. That's the direction of the magnetic field. Again, not on the outside. That's through the center. I'm going to write that here too. Okay. All right. So through the center of the tube, it's going from right to left. Okay. So, and it's increasing. So what that means is that the flux is increasing. So what that means is that the induced flux, again, Lenz's law says that the induced current is going to try to make I don't understand any of those letters. Okay, the induced flux is going to try to decrease to match it. So that means that the induced field inside of that the induced field that goes through that tube is going to go from left to right because it's going to try to make it go the other way. Okay. So again, how is it going to do that? Like I'm going to take that, I need to make a field that goes like that. So I'm going to take my thumb and I'm going to try to do it. What way can I make that happen? And when I use my thumb to do that, I have my thumb on the outside of the cardboard tube, on the outside wires of that cardboard tube, only on the side I'm using. If I flipped it the other way, I would get a different result. Actually, I get the same result. I just do it in a different manner. So I've got my thumb on the outside. My thumb is running like, in order to get it to happen, in order to get a field that runs like this, my thumb is running like that. Okay. And if that's the case, then it means that my current is going like that. Okay. And if that's the case, then for A, then my current is going from right to left. Next, we're going to talk about part B. Part B, they say the current's going from B to A. So this time our current is going this way. Our current's going like this down here. So that means our current is going this way. Okay, that's I. Okay, and if I take my thumb and do that, then I get a magnetic field that's going to run like this. pass through the center of the tube. Okay. So again, let's walk through all the steps here. So that means, and so this time I have a flux that decreases, which means I'm going to have an induced flux is going to try to counter that trend by increasing. Okay. The only way that it can do that is by making, B induced. Okay. Has to go in the same direction of that field. It's going to make it stronger. Okay. That's going to be my B induced. The only way that I can make that happen, again, I'm going to take my thumb, I'm going to run it on the winding ones only, okay? And the only way that I can make that same direction happen is if my field goes, like this, down. Okay. So that's going to make my wire go this way, because that's the same direction as those. Okay. And again, for B, that makes the current in my winding go from right to left. All right, so now we're looking at part C. Part C, it's from B to A and is increasing. Well, I mean, we can already guess since we looked at C. We know that it's going to be from left to right. I mean, it seems dumb to even go through it, but I do want to reason through it just to make sure that we all understand where it comes from. I mean, in case it was just a separate problem by itself. So again, it's going from B to A, which means that my current is going this way, okay? Which means my wires are going like this. Okay, sorry. Okay, that's I. Which means that in this case, my magnetic field going through the tube. And that's again through the center of the tube, not the outside. Okay, so that's going through the center of the tube, and which means that, and again, my flux is in this case, inside is increasing. Really. Which means that my induced flux has to decrease. Okay. And the only way that I can make that happen is if I get an induced field that goes the exact opposite way. I'm going to go ahead and draw that on here. I know it's a mess, but still. And that is B induced. Okay. In my winding, I can only make that happen. I can only make that happen if my thumb points up. Upward current this time. That's my I induced, which means this time again, my as I said before we even started the problem, that my current goes from left to right. Again, I know it's kind of pointless to go through the example when we already did B, but I want to make sure that we just thought through the reasoning for it.